Dr. M.C. Sundaraja. He completed his undergraduate studies from Madurai Kamaraj University and went on to complete his master's in structural engineering from the same. He is a doctorate from Anna University and he's also done his postdoctoral fellowship at the Queensland University of Technology, Australia. He has more than 17 years of experience in the teaching profession and he has also published papers in 39 international journals, 7 national journals, 27 international conferences and 51 national conferences. He has so far published 124 papers in various journals. He went on to receive the Best Research Paper Award from IFERP, a unit of VVERT and NIRE on 4th April 2015. He has also received Outstanding Faculty Award from the Venus International Foundation Faculty Award, VIFFA, in the year 2015. Currently, Dr. M.C. Sundaraja is now working as an assistant professor in Tyagarajar College of Engineering, Madurai.
Welcome to UGC lecture series on bioarchitecture. In the previous lecture, we have seen in detail about the behavior of one-way and two-way slabs. And the behavior of one-way and two-way slab, we have seen the classification of slabs in many categories, and also we have seen how the reinforcement has to be provided, how the slabs has to be spanned in the case of both one-way and two-way slabs. And also we have seen the differences between one-way and two-way slab. In this lecture, we are going to cover the behavior of one-way and two-way slabs, that is design guidelines as per IS 456-2000. These are all the design guidelines we must know before start designing the slabs. There are effective span of slab, loads on slab, nominal cover to the slab, minimum reinforcement required for it, maximum spacing between the reinforcement, and what is the maximum diameter of the bar to be used in the case of slab, and the types of two-way slab. As per IS 456-2000, how to find out the effective span of the slab? The effective span of the slab shall be the leisure of the following. One is the clear span plus effective depth, another one is center to center distance between the support. From these two things, the lesser value has to be adopted as the effective span of the slab. For example, this is a slab, it is supported on the walls. The thickness of wall is 230 mm, the thickness of support is 230 mm, the clear span is 3 meter and the thickness of the slab is 125 mm. Now, to find out the effective thickness LEF. First one is the center to center distance between the support. This is the center of the support and this is the center of another support. It is 3 plus 0.23, that is equal to 3.23 meter. And another one is the clear span, that is this is clear span 3 meter plus the effective depth of the slab, that is 0.125 meter, that is 3.125 meter. From this one, LEF should be adopted as 3.125 meter. The lesser value has to be selected as the effective span of the slab. Next, these are all the requirements. That's next requirement is loads on the slab. What are the loads acting on the slab? One is live load, another one is dead load. What are the dead loads on the slab? First one is self weight of the structure itself or the self weight of the slab itself. Next, above the slab, we are going to provide floor finishing, that is before floor finishing normally we are constructing the partitions, that is weight of partitions has to be also considered, then the weight of floor finishes. So, these are all the 3 loads which is coming under dead load. Dead load consists of self weight of the structure itself, weight of floor finishes and weight of partitions. Next, another major load is live load. This is normally chosen from IS 875. IS 875 which gives detail about the live load on various types of building for the various types of floors. We can by referring the IS 875, we can select the live load for the respective floor or respective rooms of the respective building. Next, nominal cover. What is the importance of the cover to the reinforcement? the reinforcement should not be directly resting over the shuttering of the slab or the centering work of slab. It has to be placed on, it has to have certain clear cover below the reinforcement. That clear cover which is normally created by means of providing the cover blocks below the reinforcement, and the thickness of the cover slab should be normally called as nominal cover in the case of slab as per IS 456. For mild exposure, normally the nominal cover as per IS 45000 is mainly depends on environmental conditions. In the case of slab, the nominal cover for the mild exposure is 20 mm. For moderate exposure, it may be 30 mm. Normally, in the case as far as our place is concerned, normally we need to choose these two exposure conditions. One is mild, another one is moderate exposure conditions. However, if the diameter of the bar do not exceed 12 mm, normally in the case of slab we are not going to use, in the case of the floor slab or the roof slab, depending upon the spanning condition, the thickness of the slab will be varied. Normally here we are not using not more than 12 mm diameter in the case of slab for our locations. The cover may be, if the diameter of the bar is do not exceed, if it is if does not exceed 12 mm, the cover may be again further reduced by 5 mm. Thus, for the main reinforcement up to 12 mm diameter bar or for the mild exposure, the nominal cover is 15 mm. Say we are going to use the 15 mm as the nominal cover for the subsequent lecture classes while doing design of the slab. And minimum reinforcement, if the diameter which exceeds 12 mm, the nominal cover should be 20 mm, that is more than 15 mm. Minimum reinforcement, that is I have already explained you. When you design the reinforcement required for the slab, that does not exceed the minimum reinforcement which is specified in IS 456. It depends on the types of steel used in the design. There are two types of steel we are using, one is mild steel, another one is the deformed bars. In the case of mild steel, if you use the mild steel, that is otherwise called the Fe 250 steel, a 250 means the characteristic tensile strength of mild steel is 250. If you use mild steel in the case of our reinforcement, the AST required should not be less than 0.15 percentage of the total cross sectional area of the concrete. If you use deformed bars, the AST which is provided should not exceed should not be less than 0.12 percentage of the total cross sectional area of the concrete. So, when you find out the AST required for the reinforcement, that has to be again checked with the minimum reinforcement as per IS 456. So, after finding out the reinforcement, first we need to know the effective span of the slab. The effective span of the slab is clear span plus effective depth of the slab or center to center distance between the support, whichever is less. After finding out the effective span of that, we need to calculate the load acting over it. There are two loads, one is dead load, another one is total load we need to calculate. Using load and the span, we are going to calculate the bending moment. Using the bending moment, we are going to calculate the depth of the slab. Then we are going to find out the reinforcement. That reinforcement again should be checked with the minimum reinforcement as per IS 456 2000. Then after finding out the area of reinforcement, we are going to find out the spacing between the reinforcement, that is most important. In the case of slab, for the area, for the whole area, we need to find out the spacing between the reinforcement. In the case of main steel, the horizontal distance between the parallel main reinforcement bars shall not be more than 3 times the effective depth of the solid slab or 300 mm, whichever is smaller. That is, first one is 3 times the effective depth of the slab, second one is 300 mm, whichever is less. The lesser value has to be adopted as the maximum spacing between the reinforcement. This is in the case of parallel main reinforcement. Next, in the case of distribution reinforcement, the spacing of the bars, that is 5 into diameter of the reinforcement or 450 mm, whichever is less. So, the spacing of distribution reinforcement should not exceed 5 into diameter of the reinforcement, 5 into depth of the slab or 450 mm, whichever is less. This is in the case of distribution reinforcement. So, the horizontal distance between parallel reinforcement bars provided against shrinkage and temperature shall not be more than 5 times the effective depth of the solid slab or 450 mm, whichever is smaller. So, the case of main reinforcement, it should not exceed 3 into depth of the slab or 300 mm, whichever is less. In the case of distribution reinforcement, the spacing of reinforcement should not exceed 5 into depth of the slab or the 450 mm, whichever is less. Now, another important thing, we need to also check the maximum diameter. So, the maximum diameter of the bore in the slab shall not exceed overall depth of the slab divided by A, that is 1/8 of overall depth of the slab, where D is the overall depth thickness of the slab. So, this has to be also considered while we choosing the diameter of the reinforcement. These are general guidelines. Now, another general guidelines here, we are going to design one-way slab and two-way slab. Another one is the continuous slab. One-way slab, the slab spanning in only one direction. Two-way slab, the slab spanning in two directions. And a continuous slab, the slab which is, that is one way continuous slab we are going to see, one way continuous slab and two way continuous slab also we are going to see. The slab which is spanned along both the directions is called as two way slab. If it is continuous over more than two supports, that is two way continuous slab. And that type of slab which is normally designed as a restraint slab. And in the case of two way slab, we are also going to see the simply supported slab which is supported on 4 walls only. And another slab is one way simply supported, that is one way simply supported slab. In the case of simply supported slab, and there are two slab one way and two way slab. In the case of two way slab, there is simply supported slab as well as restraint slab. In addition to one way and two way slab, we are going to see the continuous slab, that is one way continuous slab. In the two way simply supported slab, there are, based on the support conditions, it is simply supported slab and restraint slab. What do you mean by simply supported slab in the case of two way slab? What do you mean by simply supported, that is restraint slab in the case of two way slab? In the case of simply supported slab, simply there is no simply supported slab in the field, but in the case of simply supported slab, when it is freely supported on the walls, the four corners may be lifted up due to the load acting on the slab. It means that it do not have any adequate provision to resist the torsion which is developed at the four corners of the slab. That is, if it is resting on four walls, if the slab is not going to be built into the walls, that is, it means that the further construction of the wall over the slab is avoided. The slab is treated as it is a simply supported slab. It is freely resting on walls without any fixity which is developed at the support. So, in this case, when the load is acting on it, the four corners will be lifted up due to torsion. So, in addition to the reinforcement, when we design the slab, the torsional reinforcement of the corners has to be provided, since this slab which is not having any adequate provision to resist lifting up of the slab at the corners, or in not having any adequate provision to resist the torsion at the corners, that is called as simply supported slab. A restraint slab, if you are going to construct after providing the slab over the wall, if you are going to construct the wall over this slab. So, it means that the slab is built into the wall. So, at the supports there is a partial restraint which is developed. In order to resist this partial restraint, which when the restraint is developed at the supports. So, here it means that it has certain provision to resist the corners, that is the lifting up of corners at the four corners of the slab. So, when you have when you construct the wall over the slab, the four corners are preventing from lifting and also it is preventing from the torsion. So, here in this slab which is called as restraint slab, which is used to avoid the that is lifting up of corners at the slab, that is called as restraint slab. In the case of restraint slab, there is no chance of developing the torsion at the corners. And then how to design these two slab? They are simply supported slab and restraint slab. The simply supported slab, there is a separate codal provision to design the simply supported slab and the restraint slab. The two way simply supporters are the bending moment. How to find out the bending moments? The bending moment mx and my for the rectangular slab which is simply supported on four edges with the corners free to lift, or the slabs which do not have any adequate provision to prevent the lifting of corners, are obtained using mx is equal to alpha x into w Lx square, mi equal to alpha y into w Lx square. Here alpha x is the moment coefficients. It depends on the ratio Ly by Lx. It is given in the table, that is 27 IS 456 2000. The alpha x is the moment coefficient in the direction x and alpha y is the moment coefficient in the direction y. So, here Ly by Lx is the ratio, that is called as, it is used to divide the slab into the one way or two way slab, or the slab which is divided into a simply supported slab or the restrained slab. So, here where alpha x and alpha y are the moment coefficients given in 27 IS 456 2000 and W is the total load per unit area, Lx and Ly are the length of shorter and longer direction. This is in the case of simply supported. So, in a simply supported slab, it is simply resting on the slab which do not have any adequate provision to prevent the lifting of corners at the supports at the corner. Okay. So, there is a separate table which is used to find out the moments for finding the moments in the case of two way simply supported slab. This is a table which is used to find out the moment coefficients alpha x and alpha y based on Ly by Lx. This is a table 27. When you find out Ly by Lx, if Ly by Lx is 1.1, alpha x is equal to 0.074, alpha y is equal to 0.061. From this we can easily find out what is mx and what is my. What is the mx and what is mi in the both the direction, that is mx is alpha x into w Lx square, my is alpha y into w Lx square. By substituting the values of our moment coefficients, we can find out moment along both the direction. Then using the moments, we are going to find out the reinforcement along both the direction, that is in the case of two way simply supported slab. In this slab, the four corners are not preventing from lifting above the slab above. In addition to this reinforcement, to avoid the lifting above the corners at the in the case of slab, the corners has to be provided with the additional reinforcement that is called as torsional reinforcement, that we will see in the next slide, that is torsional reinforcement. And how to provide the torsional reinforcement we will see later. Now, here and then how to provide the reinforcement in the case of the two way simply supported slab, that is 50% of tension reinforcement provided at the midspan can be curtailed at 0.1 L or 0.1 Ly from the support, that is this is the slab which is supported. You take this as the x direction Lx and the slab reinforcement, this is the slab reinforcement has to be provided in the case of simply supported slab. Since there is no pure simply supported slab in the case of field, there is a partial restraint which is developed at the support when you construct a wall or any parapet wall at certain height. So, when you construct a parapet wall at the over the supports, the slab will bend upwards in the case of supports. So, there is a tension which is developed near the over the support at the top. To resist this, the 50% of this midspan reinforcement has to be provided over the support. It has to be cranked at 0.1 L from the face of the support. That is the reinforcement of the simply supported slab. Next one, two way restrained slab. Two way restrained slab, it means that it is different from two way simply supported slab. Two way simply supported slab means it the slab, the four corners are not preventing from lifting above the slab. But in the case of restrained slab, the restrained slab, it is the restraint is assumed over the support. So, the four corners are preventing from lifting. So, here how to design this and how to find out the moments for this restrained slab. In the case of two way simply supported slab, that is a simply supported slab, we have used table 27 to find out the bending moment from Ly by Lx ratio. In the case of two way restrained slab, there is a separate table, that is table 26, which is given in IS 456 to find out the bending moment for the restrained slab. The restrained slab, how to identify how to design it? Has the restraint slab may be an individual slab, that is it is supported on the supports. If you are going to construct the wall above, if you are going to have any another floor, this slab will be called as a restraint slab. If you are not going to construct any wall over the slab is treated as simply supported slab, since there is no restraint over this supports. In this case, the four corners of the slabs will be lifted up, but in the case of restraint slab, if you are going to construct any wall over this slab, there is a restraint which is developed over the support. So, the four corners are preventing from lifting. And how to find out the bending moment? Using tables 26, we can find out the bending. This is the example for the 9th case, that is 4 edges are discontinuous, a separate building. What about the example of other cases? There are various panels, there are moment coefficients for the various cases. One is interior panel, another one is one short edge continuous, third one is one long edge discontinuous, next one is 2 adjacent edges discontinuous, fifth one 2 short edge continuous. In similar manner, the various categories is given for finding the bending moment. So, here how to find out this one? So, here I am showing a diagram of a building. So, this is the building which is having the different panels. The different panels are designed as two-way slabs, that is a restraint slab. And how to identify the panel in these categories? Interior panel. So, in this building, the interior panels are 1. This is the example of interior panel. So, here the 4 sides are continuous one, 4 edges are continuous. Here we are having continuous, that is continuous over the support, which is having another panel also. Here we are having another panel, and here we are having the 5th panel, and here we have 3rd panel. So, here this panel is called as interior panel, and the second one is an example for one short edge discontinuous. One short edge discontinuous. Here the second panel is an example for one curve edges. So, these two edges are long edges, here 4.5 meter, here is 3.3 meter, and this is a long edge and this is a short edge, and the short edges one short edge is discontinuous and other edges are continuous. Third one long edge discontinuous. So, here this is one long edge discontinuous, you are not having any building beyond this 3rd panel, that is, and other 3 edges are continuous. Next, 4th one, 2 adjacent edges are discontinuous. 2 adjacent edges are discontinuous, other 2 adjacent edges are continuous. 2 short edges discontinuous. Here these 2 edges are short edges, 3 meter, and this one is 4.5 meter, and 2 long edges are continuous. 2 long edges discontinuous, that is 6th one. These are the short edges, these 2 long edges are discontinuous and these 2 short edges are continuous, since we are not having any building beyond the panel on the sides. Next one is 7, 3 edges discontinuous. So, here we are having this panel, in this panel 3 edges are discontinuous and 1 long edge is continuous. It has been connected with the 6th panel, but it is not having any panel beyond these 3 edges. Next, 3 edges discontinuous, 8th one, these 3 edges discontinuous, 1 short edge continuous. 9th one, 4 edges inside is a separate building. So, here this called as a restraint slab. Here we are having in the beam, the slab one is the slab which is supported over the beam, it is not freely resting on the wall. 1, that is the restraint slab. If the wall is also resting on the wall without any beam, if you are going to construct any wall over the slab is called as a restraint slab. If this wall is not constructed over the wall, over the slab will be simply supported slab. So, for these cases we need to use this table for finding out the bending moments. For the simply supported slab, with the 4 corners are not preventing from lifting, if it is freely supported on the slab on the wall, we need to use the table 27 for finding out the bending moment. And These are all the cases of this, the one-way slab and two-way slab. So, here, so we need to use these two tables for finding out the bending moment. So, here for example, the case of interior panel, how to find out the bending moment. First, you need to find out what is the ratio Ly by Lx. We all know that in the case of slab, two-way slab, Ly by Lx is less than or equal to 2. If you find out Ly by Lx, if it is 2 for interior panel, the negative moment at the continuous edge, that is the moment coefficient alpha x is 0.065, that is the negative moment coefficient at the continuous edge. What is the positive moment coefficient for alpha x in the x direction? That is 0.049. For the long span coefficient on this direction, there is a negative moment as well as positive moment. For negative moment, it is this is negative moment and this is positive moment. Since it is a restrained slab, there is a negative as well as positive moment on each side. On this side, there is a positive moment and here the negative moment. On this side, we are having negative moment and here we are having positive moment. So, using this moment coefficient, what do you mean by moment coefficient for in the case of a slab which is simply supported, which is subjected to uniformly distributed load, this is the bending moment. From this 1 by 8 is called as the moment coefficient. Here these are all the moment coefficient for this two-way slab. So, here this is alpha x and alpha y and alpha y, that is negative, positive, that is 0.032 and here it is 0.024. And using these 4 moments, so on y direction we are having 2 moments, on x direction we are having 2 moments. So, on x direction we are going to select the maximum bending moment, on y direction again we are going to select the maximum bending moment, then we are going to design the reinforcement on the respective direction for the maximum bending moments. This is in the case of two-way simply supported as well as restrained slab. For example, in the case of one-way simply supported slab, the bending moment is W L square by 8. For one-way continuous slab, we are going to use the moment coefficients for finding on the moment at various places. That is we have seen in the case of continuous beam. That same moment coefficients we are going to use for continuous slabs also. Now, I summarize this lecture. In this lecture, we have seen in detail about how to calculate the moment coefficient for finding the bending moment in the case of two-way simply supported slab as well as two-way restrained slab. Before that, before finding this bending moment, we have seen the various factors. One is effective span of the slab, how to find out the effective span of the slab, and how to find out the loads acting on the slab, what is the nominal cover to be used for the slab. After finding out the reinforcement, that reinforcement has to be checked with the minimum reinforcement given in the course. So, the reinforcement required against the bending moment should not exceed the minimum reinforcement. Next, the maximum spacing. After finding out the reinforcement, we are going to find out the spacing between the reinforcement. That spacing, required spacing should not exceed the maximum spacing given in the code book. And also, when you select the diameter of the reinforcement, that diameter of the reinforcement should not exceed the maximum diameter of the bar which is given in the ISP, that is 1/8 of the overall depth of the slab. And also we have seen the different types of two-way slab, that is simply supported slab, restrained slab. In connection with this lecture, the questions may be asked. Explain about what are the IS codal provisions for finding the effective span of the slab, what is the nominal cover for the slab, what is the minimum reinforcement to be used in the case of slab, what is the maximum spacing of the bar which should be used in the slab, and what is the maximum diameter of the bar to be used in the case of slab. And we can also know how to differentiate between the two-way simply supported slab and two-way restrained slab, that is along with the behavior, along with the locations. And in this connections, the references are IS 456-2000 plain and reinforced concrete code of practice, and IS 875 code of practice for design loads other than earthquake forces for buildings and structures, and another handbook that is for detailing of reinforcement, that is Handbook of Concrete Reinforcement and Detailing, that is SP 34 1987. And with regard to the books, the Reinforced Concrete Design which is written by S. N. Sinha, which is published by Dr. McGraw-Hill Publishing Company Limited. And another books which is written by Ashok K. Jain, that is Reinforced Concrete Limit State Design, which is published by Nemchand and Brothers. Thank you very much.